This is section 3.2, States and Properties of Matter. So a state of matter is solid, liquid, gas. It's basically has to do on the energy of the matter that has connections or attachments or pull or forces that want to attract to other molecules or other atoms. And so if you give it enough energy, they can break that matrix and become a liquid, slosh around. If you were to gain more energy, you could actually become a gas and bump off the walls and ceiling. So that is one type of matter that's in different phases, so solids, liquids, and gas, and that's called a state of matter. And then properties of matter is a description of that matter. So is it something you can see physically with your eyes, such as its color, or measure with like its boiling point? That would be a physical property. And then chemical properties are going to be, how does it react with other elements or other compounds? Is it reactive? Is it not reactive? So let's look at some of these. So they have proper characteristics called physical properties, descriptors, and chemical properties, whether or not they react with something else. So let's start with physical properties. So something you can observe in order to identify it. So you can observe when it boils or when it freezes, when it melts. Those are specific things that you can make an experiment about it, melt a piece of ice, note its temperature when it melts, when it finishes melting, when it boils, and then you can write those things down. And all elements and compounds have been tinkered with this way to where you could actually say this element has a certain color, it has a certain boiling point, it has a certain density. You can have a certain volume of that material and find out how much it weighs. So what is its mass per volume ratio, or what's its density? Those kind of things that you can see, that you can measure, that has nothing to do with whether it's going to react. Its reactivity is a chemical property, but what you can see about it, what you can measure, does it conduct electricity, or does it conduct heat? Those are all physical properties. So here's just an example, physical properties of copper. Okay, it's solid at room temperature. It has a melting point of a certain degrees. It has a boiling point of a certain degrees. It's shiny. It has a certain color. It conducts heat and electricity, so you can make wires out of it for electric wires. You could make copper pans to cook food in. So these properties have a lot to do with why it's used or how it's used. So in the states of matter, you have solid, liquid, and a gas. A solid, everything is so compact that it's in a very specific matrix, almost like a specific 3D shape, and it holds its shape. So it has a definite shape. It doesn't just take any shape of its container. It maintains its shape even if you put it in a different container. Liquids have lost its attraction from one molecule to the next, and so it'll slosh around. And because it sloshes around, it can take any shape. It can take the shape of its container, but it definitely has a certain volume. A gas doesn't have a special volume. It fills whatever container it is. Now, you might have high pressure of the gas or a low pressure, but no matter how big that the vessel is, whether it's a small jar or a whole room, it would fill the room. Now, there might be lots of empty space between it, but it still fills it. So it doesn't have a definite volume, and it doesn't have a definite shape. It maintains the shape of the container that it's in. So here's just a comparison between them. So you have basically a solid has a definite shape, definite volume, very close together, and the particles have an interaction. There's a strong attraction between one molecule or one atom and the next in the sample. Liquids do too, but less so. So they can slosh past each other. A gas has almost no binding at all between one molecule and its adjacent molecule. And so the movement of a solid would be slower, a liquid would be faster, molecular movement, and a gas very, very fast. So if you change state, you would say melt ice. You would turn solid into a liquid. That would be melting. You could boil water, turning a liquid into a vapor. That's boiling. You could take a vapor and condense it back into a liquid. That's condensation. And you could take that liquid and freeze it into a solid. That would be freezing. So physical change is if you change anything that doesn't change it into something new. So you change its shape, you tear it into small pieces, or you break it into pieces, or you cut it into pieces, or you hammer it into sheets, or you pull it into wires. It's still the same stuff. If you have the same stuff at the end, you've changed it physically, but you haven't changed it into something else. A chemical change would be when you change it into a new material. So a chemical property is something that you could describe as having happened in a chemical reaction. It changes into a new substance. So like a shiny iron nail rusting, the oxygen in the air is reacting with that iron to make iron oxide, which is rust. And that rust is new with new properties. It has a different color, it has a different shape, it has everything new than the original iron nail. And so that's chemical properties. If you change something chemical, you're changing something into a new substance. You're rearranging the atoms in it with new bonds and new properties. So you turn something from one thing into another. That's a chemical change, and it requires new properties, something new happening. So tarnishing of silver, burning of wood, that's not the same as breaking something into smaller pieces. So I hope this makes some sense to you and it helps you a lot.